Hey guys, so we are continuing our series of Ethereum documentation and now we have reached to nodes and clients. So let us continue. Nodes and clients. Fine. Ethereum is a distributed networks of computer known as nodes running software that can verify blocks and transaction data. Huh? Nodes are running the software. What is the software? That's a Ethereum virtual machine. The software must be run on your computer to turn it into Ethereum node. Fine. There are two separate pieces of software required to form a node. Two pieces of software that require to form a node. We'll see that prerequisites. You should understand the concept of peer-to-peer network and the basics of EVM. I know before diving deeper into and running your own instance of the Ethereum client. Fine. Take a look at our introduction to Ethereum. Fine. If you are new to the topic to the nodes, we recommend first checking out our user-friendly introduction to running an Ethereum node. Running an Ethereum node. Where is that? Should we go to that first? I think we should go. Where are we? No, we are supposed to be in nodes and clients. If you are new to the nodes, we recommend you checking out user-friendly introduction to running an Ethereum node. Yeah, I want to check. Okay, so it has redirected us to a different page. It is ethereum.org run a node. Fine. Let us check what is required to run a node. Ta-da-da-da. Take full control, run your own node. What does it mean to run a node? Run software known as client. Running a node means running a software in your computer. That software is a client. This software downloads a copy of the Ethereum blockchain and verifies the validity of every block. ठीक है? एक पूरी copy आएगी and every block will get validated. Then keep it up to date with the new blocks in transaction and help other downloads and update their own copies with hardware. Ethereum is designed to run a node on average consumer grade computer. Okay, so we don't need a very extraordinary hardware for the same. You can use any personal computer, but most users opt to run the node on a dedicated hardware to eliminate the performance impact on the machine, minimize node downtime. So generally, yeah, you can run that on your own PC, but mainly users prefer to use a different hardware for the same. While online running an Ethereum node, you may sound complicated. नहीं, रीडिंग गंदी होगी क्या? While online running an Ethereum node may sound complicated at first, but it's merely the act of continuously running client software on computer while connected to the internet. While offline, your node will simply be inactive until it gets back online and catches up with the last changes. Fine. So it will catch up all the changes whenever it will come online again. What next? You should run a who should run a node? Everyone. हाँ भाई सब run करो क्या दिक्कत? No one, not just for proof of stake validators. Anyone can run a node. You don't even need ETH. Even if you don't have ETH, yeah, you can run a node. Don't need to stake ETH to run a node. In fact, it's every other node on Ethereum that hold validator accountable. So you don't need to have some ETH in order to run a node. You need to have 32 ETH in order to become a validator. Fine. You may not get the financial rewards that validator earn, but there are many other benefits of running a node for an Ethereum user to consider, including privacy, security, reduced reliance on third-party servers, censorship resistance, and improved health and decentralization of the network. What are the benefits of running your own node? First, privacy, security. Third is reduced reliance on third party like Alchemy or Infura. Security, privacy, third party reliance removal, censorship resistance. And fifth is for all the community. Like if you'll run a node, then number of nodes will increase and overall system will become more stronger. Having your own node means you don't need to trust information about the state of the network provided by third party. Definitely, you are not running a node. You are just asking a third party that, hey dude, what is the status of the blockchain? And it just tells you uh, according to its own server. It might not say the really truth thing. Don't trust, verify. Yeah, that's the motto. That's the sole motto of blockchain. That don't trust, verify by its own, by own. How can you do that? By running your own node. Why run a node? Privacy, security, censorship resistance, participate, decentralization, voice, voice your choice, sovereignty. Okay, so these are the six key concepts given in why run a node section. Fine, fine, fine. Getting started. Blah 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 blah. Choose your adventure. You need some hardware to get started. Although running a node software is possible on personal computer, having a dedicated machine can greatly enhance the performance of a node while minimizing its impact on a primary computer. Fine. When selecting hardware, consider the chain is continually growing and maintenance will inevitably be needed. Increasing specs can have delay the need for node maintenance. Increasing specification can delay the need for node maintenance. ठीक है, specification बढ़ाओ भाई. Fine. Buy fully loaded now. Build your own soft. What is this? Step one, hardware. What is it telling? Build your own. Okay, so it's telling us what is required to in order to build a in order to run a RAM. Oh, sorry, in order to run a node. Hardware minimum specification 4 से 8 GB RAM, C note on staking, C note on Raspberry Pi, fine, 2 TB SSD at least. Recommended, what is recommended? Intel NCU 7 Gen or higher. Okay. Wired internet connection, fine. If not required, but provide easier setup and most consistent connection, fine. I must make it so. Yes. Display screen and keyboard. Keyboard तो रखो भाई, display screen भी रख लो. Step 2, software. Option 1, dApp node. When you're ready with your hardware, the dApp node operating system can be downloaded using any computer and installed onto a fresh SSD via USB drive. Okay. So whenever the hardware is set up, you're supposed to install a software that is dApp node. dApp node. Option second, command line. For maximum control, experienced user may prefer using command line instead. You should use command line only if you are experienced. Noobs should use dApp node. Fine. For maximum control, experienced users can prefer using the command line instead. Okay, see our develop docs for more information. Getting started with the client section selection. Sorry. Bye. Okay. Find some helpers. Online platforms such as Discord or Reddit are home to a large number of community builders willing to help you with any question you may encounter. Don't go at it alone. If you have a question, it's likely someone here can help you find the answer. You can join the Tab Node Discord. Fine. I think that's all. No, there's something else. Plan on staking recommended, but 32 is better. Bhai sahab. It's saying that 16 GB RAM is recommended, but if you can afford 32 GB, then it's very nice. With a CPU benchmark score of 6667 plus on cpubenchmark.net. It's also recommended that stakers have access to unlimited high-speed internet bandwidth, though this is not an absolute requirement. Definitely, for being online, you must have access to internet. That's why they ask you that you must have absolutely large amount of internet network accessibility. Each taker goes into more detail in this hour-long special. Okay, note on Raspberry Pi. Don't want to read. Fine, पढ़ लिया अपन ने. Back वापस आते हैं अपने nodes and clients पे. Prerequisites completed. What are nodes and clients? Nodes an instance of Ethereum client software that is connected to other computers also running Ethereum software, forming a network. What is a node? Node is a computer that is running client software connected to other computers in the Ethereum network. Fine. Correct. Forming a network. Okay. Client is an implementation of Ethereum that verifies data against the protocol rules and keeps the network secure. What does a client do? Client checks all the data in the blockchain. A client is an implementation of Ethereum that verifies data against the protocol rules. It verifies data against the protocol rules and keeps the network secure. Node has to run two clients, consensus client and an execution client. If you are running a node, then your hardware must run two clients. One is consensus client, one is execution client. नाम से समझ में आ रहा है, like consensus client will be used to connect, to make consensus, to agree with all the computers state. Execution client, all the execution part that's been done on the network. Let's check the execution client, also known as execution engine, EL client or formerly ETH1 client. पहले कौन सा आया? Execution client. We are reading execution client, also called execution engine, EL client, and third one ETH1 client. execution client, also called execution engine, EL client, and ETH1 engine client. Listens to new transaction broadcasted in the network, executes them in the EVM, and holds the latest state and database of the current Ethereum node. Execution client क्या करता है? It listens to the new transaction in the blockchain broadcasted in the network. Means it's not for minting something. It's for listening to the transaction. As per I understand from this line, might be different. Let's read. Okay. So it checks for the newly broadcasted transactions into the network. It executes them in the EVM and holds the latest state and database of all the current Ethereum data. It executes all the transactions and holds the latest state and database of all current Ethereum data. Holds the latest state of the and database of all the current Ethereum data. ठीक है, जो भी data Ethereum पास है उसका current state will be dealt with by execution client. Fine. Consensus client क्या करता है? Also known as beacon node, CL client, or formerly the ETH2 client. एग्जीक्यूशन क्लाइंट क्या क्या पढ़ा था? एक एग्जीक्यूशन इंजन कहते हैं इसको, और ईयर क्लाइंट कहते थे, और कुछ भी कहते थे, ईथ वन क्लाइंट, एंड दिस वन बीकन, बीकन दिस कॉल्ड बीकन, बीकन क्लाइंट, सीएल क्लाइंट और ईथ टू क्लाइंट. फाइन. Implement the proof of stake consensus algorithm handled in consensus client. What's consensus algorithm Ethereum use currently? It's proof of stake sorry, which enables the network to archive agreements based on validated data from the execution client. Execution client validates the data and consensus client used to circulate the data amongst the peers, which enables the network to archive agreement based on validated data from execution client. There's also third piece of software known as validator that can be added to the consensus client, allowing a node to participate in securing the network. So the consensus client can also contain one more component, might be considered as a third component, but it's given under the consensus client only. That is a validator that is used to make the network more secure. How will the network become more secure? The new block will come. This validator will check whether this block is valid or not, and if it is valid, then consensus client will overall process the same and store it in the local storage, saying ki, ha bhai, this one is fine. These clients work together to keep track of head of the Ethereum chain and allow user to interact with the Ethereum network. Work together to keep the track of the head of the Ethereum chain and allow user to interact with the Ethereum network. Fine, user can interact with Ethereum network. Why? Because every state was being stored in this execution, in this consensus client. Execution client. नहीं execution client में store हो रहा है. How the latest state and data execution client में store हो रहा है. Fine. First of all, consensus client में आया the implements process execution client. Execution client will validate the data, then consensus client will circulate it to everywhere. Means first of all the transactions come to execution client, it will validate, and then will get to go to consensus client. Fine. These clients work together to keep the track of the head of the Ethereum chain and allows user to interact with the Ethereum network. The modular design with multiple pieces of software working together is called encapsulated complexity. Modular design of these two clients encapsulated into a single bundle is called encapsulated complexity. This approach made it easier to execute the merge seamlessly, make client software easier to maintain and develop, and enables the reuse of individual client, for example, in layer 2 ecosystem. I don't understand this line at all. This approach make it easier to execute the merge seamlessly. Which approach? Execute encapsulated complexity means there's not a single client, there are two clients, execution and consensus. This approach made it easier to execute the merge seamlessly, makes client software easier to maintain. Why is it easier to maintain? Because it's broken down to two components. and develop and enables the reuse of individual clients. Enables the reuse of individual clients. For example, layer 2 ecosystem, Ethereum client, Web3 library. Web3 libraries goes to Ethereum client, and Ethereum client is being, no, Ethereum clients are connected P2P. Huh. And execution engine and beacon node are connected, means execution engine and consensus engine are connected through engine APIs. Okay. Simplified diagram of coupled execution consensus client. ठीक है. Client diversity. Both execution client consensus client exist in a variety of programming language developed by different teams. Multiple client implementation can make the network stronger by reducing its dependency on a single code base. ठीक है. ज़्यादा code base, ज़्यादा language implementation है, like it's being implemented different languages like JavaScript, Python, Go, Ruby, Rails, might be on Rust as well, or TypeScript, or some languages that I might be forgetting. The ideal goal is to achieve diversity without any client dominating. The ideal goal is to achieve diversity without any client dominating the network, thereby eliminating a potential single point of failure. The variety of languages also invite a broader developer community and allows them to create integrations in their preferred language. What does it mean? If you are a Python developer, then you need to not to learn JavaScript in order to put your understanding of blockchain into the blockchain original, into the EVM's original code. You can just go to the Python's code base and um, code whatever your understanding is about, and if it's valuable, then other developers can copy your logic from your language to their language, so that this makes the system even more stronger. Variety of language also invites a broader developer community that allows them to create integration their preferred language. Learn more about client diversity. What these implementations have in common is they all follow single specification. Specifications dictate how Ethereum network and blockchain function. Every technical detail is defined and specifications can be found as originally Ethereum yellow paper, execution specs, consensus specs, EIP implementation in various network upgrades. We will read them, but after completing at least the basics of blockchain Ethereum documentation, fine. We will definitely read yellow paper as well. But first of all, read documentation, then go to white paper, and then after completing all this, we will jump to yellow paper as well. Yo, tracking nodes in the network. Multiple trackers offer a real-time overview of node in the Ethereum network. Note that due to the nature of decentralized network, these crawlers can only provide limited view of the network and might report different result. Tracking nodes in the network. So what is this? Like you can track the nodes of the network. Multiple trackers offer real-time overview of the node in the Ethereum network. Note that due to the nature of the decentralized network, these crawlers can only provide a limited view of the network, might report different results. Okay, if you want to check where are the nodes situated in which country, then you can just go through map of nodes, ether node, ethereum node crawler, and node watch. Fine. Node types. If you want to run your own node, you should understand that there are different types of node that consume data differently. In fact, clients can run three different type of node: light, full, archive. There are also options of different sync strategies which enable faster synchronization time. Synchronization refer to how quickly it can get the most up-to-date information on Ethereum's state. What does synchronization means of GitHub on GitHub? Like you should be able to pull all the updated code. What does it mean in Ethereum? You must be able to pull all the latest updated Ethereum state. Yeah, that is Ethereum synchronization. Full node. Full node क्या होता है? Definitely something full. Full node do a block to block validation in the blockchain. ठीक है? Including downloading and verification. Sorry. Full node do a block to block validation of the blockchain, including downloading and verifying the block body and state data for each block. Oh my god. Then it must take a large amount of time. Why? Because it's just checking each and every block. One Genesis block verified. One block number one verified. Block number two verified. Large number of blocks have been minted, bro. You might get bugged. Really. Full nodes do a block by block validation of the blockchain, including downloading and verifying the block body and state data for each block. Block body and state data for each block. My god. There are different classes of full node. Some start from the Genesis block. Okay. and verify every single block in the entire history of the blockchain. Others start the verification more recent block that they trust to be valid. Fine. So there are some full nodes which verify the data from going up to the genesis, but there are some who verifies from a node which is valid, which is considered to be valid, like Gits and SnapSync. Regardless of whether verification starts, full node only keep a local copy of relative recent data. Full node keep a local copy of relatively recent data, like around 128 blocks, allowing older data to be deleted to save disk and space. Older data can be regenerated when it is needed. Store full blockchain data, although this is periodically pruned, so a full node does not store all state data back to Genesis. Means they have already, means whatever they store the full block. Fine. Like if they are storing 128 blocks, then they must be having completely 128 blocks. It's not like they're just having part of it. We'll see that in light mode. I know a little bit about that. Allowing older data to be deleted to save disk space. Older data can be regenerated when it is needed. How is it regenerated? We'll see after 2 minutes. Let me give but tell you it's archive mode. Okay. Participate in block validation verifies all blocks and states. This participates in block verification. It verifies all the blocks and the states. Fine. Sorry. All states can be either retrieved from local storage or regenerated from snapshots by full node. What? All states can be either retrieved from local storage. All the states can be retrieved from local storage. So was there a local storage as well? Or regenerated or regenerated from snapshots by a full node. All the states can be retrieved by local storage if saved in it or from other full nodes. Serves the network and provide data on request. It serves some request, it serves some network. Archive node. Archive node are full nodes that verify every block from Genesis and never delete any of the downloaded data. This is a large full node, we can say. Here, the data is not deleted at all. Once the data is stored into the archive node, it's completely and permanently stored. It will not delete it. So you can just go and query the archive node that what was the data to, yeah, full node. Participate in the block validation, verifies all the blocks and states. All state can be either retrieved from local storage or regenerated from snapshots by a full node. And it serves the network and provides data on request. This is all about full node. Let's jump into archive node. Archive nodes are the full nodes that verify every block from Genesis and never delete any of the downloaded data. These are exactly like the full nodes, but only difference is that full node deletes a data that's older from around 128 blocks. But what about archive node? They do not delete any of the data. They are just considered as a storehouse of all the data in the blockchain. They stores everything kept in the full node and builds an archive of historic states. If needed, if you want to query something like an account balance at block number hash 4 million, sorry, or simply and reliable test your own transaction set without mining them using tracing. Sorry. This data represents units of terabytes, which make archive nodes less attractive for average user but can be handy for services. This data represents units of terabytes, like the units of the units are in terabytes, like a large amount of data is there, which makes archive node less attractive for average users, but they can be handy for services like block explorer, wallet vendors, and chain analytics. Yeah, that's true that not every node runner will opt for archive node, but yes, they will be used for some specific purposes like block explorer, like wallet vendors and chain analytics, and etc. Syncing clients in any mode other than archive will result in pruned blockchain data. This means there's no what is pruning? Yeah, What is the meaning of prune? Trim, by cutting away dead or branches of specially encouraged growth. Okay, so that means a trimmed one. Trim blockchain. Syncing clients in any mode other than archive will result in prune blockchain data. If you sync from any other node apart from archive node, then you'll get an pruned blockchain data, the trimmed one. What if you'll archive from, what if you'll sync from an archive node, you'll get a complete blockchain. Fine. There's no archive of all historic state, but all the full node is able to build them on demand. What does it mean? Full node can build them on demand. How? Because they can go to the archive node, ask bhaiya bhaiya data de do. The third type is light node. Instead of downloading every block, light node only download block headers. These header contain summary information about the contents of the block and information. They just contain the block headers. They don't contain even the material inside the block. Any other information the light node require get requested from the full node. They request data from the full node. So you ask that what is the use of light node? Uh, what I think is it resolves the issue. Like no full node can provide you the incorrect data, the tampered data, because you are still holding the block header, right? If you'll find that the data is not matching with your block header, then you can just say that, hey dude, this is not the correct data, let me ask someone else, some other full node. Instead of downloading every block, light nodes only download block headers. These headers contain summary information of the contents of the block. Any other information the light node require get requested from the full node. Okay, they are dependent on full nodes. The light node can then independently verify the data they receive against the state roots in the block header. Yeah, that just is it. They have the state headers. They can just verify, they can just cross check whether the data is right or not. Light node enable user to participate in the Ethereum network without the powerful hardware or high bandwidth required to run full nodes. Eventually, light node might run on mobile phones or embedded devices. Light nodes might run on mobile phones or embedded devices. The light nodes do not participate in consensus. That is, they cannot be miners or validators. Yeah, that's the thing. Actually, no. Full nodes and the archive node can be. So fine. Light nodes cannot participate in consensus, but they can access the Ethereum blockchain with the same functionality and security guarantee as a full node. Just we have discussed. Light clients are an area of active development for Ethereum, and we expect to see new light clients for the consensus layer and execution layer soon. Light clients for execution consensus layer. Fine. There are also potential routes to provide the light client data over the gossip network. Gossip network. There are also potential route to provide light client data over the gossip network. What the fuck is this gossip network? Oh my god, there's a there's a complete network named gossip. Concept. What is the concept? A protocol concept, content key, hash, accumulators, clients, train, fluffy, ultra light bridge node blog. My god, this is a whole new documentation series. I'm not gonna read it. I'm just going out. I'm just leaving that. Okay. Potential route for providing light nodes. So what I understand is a gossip network is a kind of network that provides accessibility of light nodes to any computer hardware whoever wants. This advantageous because a gossip network could support a network of light nodes without requiring full nodes to serve request. Network of light nodes without full nodes. What are they doing, man? How? Where are you storing the blockchain block data, block transactions? That's a mystery. Ethereum does not support a large population of light nodes yet, but light node support is an area expected to develop rapidly in the near future. In particular, clients like Nimbus, Helios, and Lodestar are currently heavily focused on light nodes. So yeah, so these three clients, Nimbus, Helios, and Lodestar, I believe these are three providers which are focused on light node providing high light nodes. Why should I run Ethereum node? Now the question that might arise in your mind is, why should you run an Ethereum node? We've also read it earlier that it will give you security, it maintains privacy, it will give you um, access to the real data, like no tampering with your data, censorship resistance will be provided, and fourth one was the overall Ethereum system will become stronger. You're running a node. It's so sad. Just a sec. Running a node enables you to Ethereum use Ethereum in a private, self-sufficient, trusted manner. You don't need to trust the network because you can verify the data yourself with your client. Don't trust, verify, the popular blockchain mantra. Why run? Because you can yourself verify the data that's incoming. Benefits to you. Running a node enables you to use Ethereum in a private, self-sufficient, trustless manner. Private, self-sufficient, trustless manner. You don't need to trust the network because you can verify the data yourself with your client. Don't trust, verify, blockchain mantra. ठीक है? Your node verifies all the transaction blocks get against consensus rules by itself. ठीक है? This means you don't have to rely on any other node in the network to or fully trust them. You will verify the data yourself. You can use Ethereum wallet with your own node. You can use dApps more securely and privately because you won't have to leak your addresses and balances to intermediaries. dApps can be used securely without any third-party intervention. Everything can be checked with your own client. MetaMask, Frame, and many other wallets offer RPC importing, allowing them to use your own node. Just as we have seen that MetaMask asks for an RPC URL if you are using any other service like Infura or Alchemy, you just provide their URL. But what if you are running your own node? Then you can just copy it from that and paste it here in order to uh, import your own node service in these wallets like MetaMask and Frame. You can run and self-host other services which depend on data from Ethereum. For example, this might be a beacon chain validate. You can run self-host. You can run and self-host other services which depend on the data from Ethereum. Oh my god! You can also run a business using a node, like just as in Pura and Alchemy, like you can yourself do something, just like providing beacon chain validator software like layer 2 infrastructure, block explorer, payment processor, etc. So many options are there, bro. You can provide your own custom RPC endpoint. हाँ, मैंने नोड चलाया. I'll provide you the RPC endpoint. You can use it. You can just ask data from my node, and that's a subscription based model. You can provide your own RPC endpoint. You could even offer these endpoint publicly to the community to help them avoid big centralized providers. ठीक है? You can connect to your node using inter-process communication (IPC). IPC, inter-process communication. Fine, I know that. You can connect your node using inter-process communication or rewrite the node to load your program as a plugin. This guards low latency, which helps a lot. Example, when processing a lot of data using web libraries or when you need to replace a transaction as fast as possible. Example, front running. You can directly stake it to secure network and earn rewards. See solo staking to get started. Staking, solo staking, okay. Network benefits. All we have discussed was your personal benefit. If you're running a node, then overall network is also benefited in some manner. Let's read. Diverse set of node is important for Ethereum's health, security, and operational resiliency. Full nodes enforce the consensus rule so that they can't be tricked into accepting blocks that don't follow them. Full nodes enforce the consensus rules. More the full nodes, more the security. so they can't be they can't be tricked accepting blocks that don't follow them. ठीक है. They provide extra security in the network because if all the nodes were light nodes which don't have full verification, validator could attack the network. In case of an attack which overcomes the crypto economic defenses of proof of stake, a social recovery can be performed by full node choosing to follow the honest chain. In case of any glitch or any mismatch, um, full nodes can just go to the honest answer, like which data is present in most of the full nodes, and that can be accepted as the correct one. More nodes in the network result in a more diverse and robust network, the ultimate goal of decentralization, which enable a censorship resistance and reliable system. More nodes in the network result in more diverse and robust network. More nodes, more diverse, more robust network. Ultimate goal of decentralization enables censorship resistance and reliable system. Full nodes provide access to blockchain data for lightweight lines that depends on it. Light nodes doesn't store the whole blockchain. Instead, they verify data via the state roots and block headers. Full node provide access to blockchain data for lightweight lines. Full nodes. हाँ, full node provide access to blockchain data for lightweight line that depend on it. ठीक है. Light node don't store the whole blockchain. Instead, they verify data via the state root in block headers. Fine. They have their block headers. They can request more information from full nodes if they need it. Yeah. If you run a full node, the whole Ethereum network benefits from it, even if you don't run a validator. If you're running a full node, then the Ethereum network is going to benefit from it. So they must pay us. Okay, fine. Running your own node. You're running your own node. Interested in running your own Ethereum client? For the beginner-friendly introduction, visit Run a Node page to learn more. I have already did all this, and you also. If you are more of a technical user, dive into more details and options on how to sign up your own node. Alternatives, setting up your own node can cost you time and resources, but you don't always need to run your own instances. In this case, you can use a third-party API provider. For an overview of these services, check out Node as a service. Node as a service. Yeah, we'll be reading it in a short time, very quickly. Okay. If somebody runs Ethereum node, if somebody runs Ethereum node with a public API in a community, you can point your wallet to a community node via custom RPC and gain more privacy than with some randomly trusted third party. Yeah, that's already told that you can connect others with your RPC. Just it's saying in different words. On the other hand, if you run a client, you can share it with your friends who might need it. Coming to execution client, the execution community maintains multiple open source execution clients previously known as Ether client or just Ethereum clients developed by different teams using different programming languages. This makes networks stronger and more diverse. The ideal goal is to achieve diversity without a client dominating to reduce any single point of failure. This table summarizes the reference client. All of them pass client test and are actively maintained to stay updated with the network upgrades. So it is giving some clients. Clients means what? Client softwares which are being installed on nodes. Fine. They contain both Ethereum, execution client and what was that? Consensus client. Consensus client. Git written in Go. It's short form for Go Ethereum. ठीक है. Operating system Linux, Windows, Mac OS, mainnet, Cipolio, Curly, Snapful. ठीक है. ये archive pruned. ठीक है. Archive भी हो सकता है, prune भी हो सकता है. State purity archive मतलब पूरा डेटा भी अंदर आ सकता है. Prune मतलब आधा डेटा भी अंदर आ सकता है. Fine. Definitely. Second one is neither mine. C Sharp, .NET, Linux, Windows, Mac OS. Okay, fine. ठीक है. Neither mine. C Sharp, .NET, Besu in Java, Aragon Go, Rust. Oh my God, no one is in JavaScript or TypeScript. Fine. For more on up, for more on supported networks, read up on Ethereum network. Each client has unique use case and advantage, so you should choose one based on your own preferences. Diversity allows implementation to be focused on different features and user audiences. You may want to choose a client based on features supporting programming language or licenses. Each client has unique use cases and advantage. Definitely. You should choose one based on your own preferences. Diversity allows implementation to be focused on different feature user audiences. You may want to choose a client based on features supported programming language or licenses. Choose wisely, just like mutual funds. Just like mutual funds are subject to market risk, so read all the scheme related documents carefully. Besu, Ericon, Besu, yeah. The question: Besu was a client of which language? It was written in Java. Let's see. Yeah, I win. Hyperledger Besu is an enterprise-grade Ethereum client for public and permission network. Fine, Hyperledger before करता है Hyperledger Besu. ठीक है, public and private networks. It run all the Ethereum mainnet feature from tracing to GraphQL, has extensive monitoring and is supported by consensus both in open community channel and through commercial SLAs for enterprises. It is written in Java and Apache 2.0 licensed. Besu's extensive documentation will guide you through all the details of feature and setups. Aragon. Aragon, formerly known as the Turbo Geek, started as a fork to go Ethereum oriented towards speed and disk space efficiency. Aragon is a completely re-architected implementation of Ethereum currently written in Go. Aragon is written in Go, but with implementation in the language under development, Aragon's goal is to provide a faster, more modular, and more optimized implementation of Ethereum. It can perform full archive node syncing using around 2 bits of disk space in under 3 days. ओ भाई 3 दिन लग जाते हैं एक syncing के लिए. It can perform a full archive node sync using around 2 TB of disk space. Full node, full blockchain syncing from the archive node of from Genesis block with a storage of 2 TB with a time of around 3 days. Go Ethereum. Definitely Go में लिखी होगी. Go Ethereum is one of the original implementation of the Ethereum protocol. Currently, it is the most widespread client with the biggest user base and variety of tooling for user and developer. It is written in Go, fully open source and licensed under the LGPL v3. Nethermind Ethereum implementation created with the C#.NET tech stack, licensed with LGPL 3.0, running on all major platforms including ARM. It offers great performance with an optimized virtual machine, state access, networking, and rich feature protocols like Prometheus, Grafana dashboards, SQL Enterprise logging support, JSON RPC tracking, and analytics plugin. Nethermind also has detailed documentation. ठीक है? Strong dev support, online community, 24/7 support available for premium users. Fine. Consensus clients. अभी तक जो पढ़ा था इथेरियम क्लाइंट्स थे क्या? मैंने कुछ बोला तो नहीं था. एग्जीक्यूट सॉरी नहीं. Fine. So what we were reading these four: Geet, Besu, Nevermind, Neithermind. Sorry, Nevermind. Oh, Geet, Aragon. Aragon is in Aragon किस language में है भाई? Aragon. Aragon is also in Go. Oh my God, Geet and Aragon both are written in Go. Rith is written in Rust. Bhai. Consensus clients. The multiple consensus clients, previously known as ETH2 clients, to support the consensus upgrades, they are responsible for all the consensus related logic, including the fork choice algorithm, proceeding attestation, and managing proof of stake rewards and penalties. Actually, what Ethereum has done is a very intelligent type of thing. They have divided the execution client and the consensus client. If they want to make changes in the execution, they are just supposed to make changes in the execution clients like Need and Neithermind. And if they want to change some protocol in consensus, like they just wanted to shift from proof of stake to proof of work to proof of stake, what they might have done is they have just changed the consensus clients instead of changing both of them. That's a very intelligent move. There are multiple consensus clients, previously known as ETH2 clients, to support the consensus upgrades. They are responsible for the consensus related logic, including the fork choice algorithm, fork choice, hard fork, soft fork, कैसा fork होगा, processing attestation, and managing proof of stake rewards and penalties. Client, language, operating system, networks. Clients, there are several clients like Lighthouse, written in Rust. Network कौन सा है? Beacon chain, Goerli, Pyrmont, Sepolia, Robston, and more. Lighthouse, Lighthouse is a consensus client written in Rust. Fine. Load Star, Load Star, Nimbus, Nimbus is written in language Nim. भाई ये कौन सी लैंग्वेज आ गई देख? निम कौन सी लैंग्वेज होती है? ठीक है चलो होती होगी. Nimbus. Prism is written in Go and Teku is written in Java. जावा में बेसू था और टिका है टिकू. Lighthouse. Lighthouse, a consensus client implementation written in Rust under the Apache 2.0 license. It is maintained by Sigma Prime and has been stable. Is maintained by Sigma Prime. एक बंदा मेंटेन करता है, एक कम्युनिटी है कोई सी. It's maintained by Sigma Prime and has been stable and production ready since Beacon chain genesis. It is relied upon by various enterprises, taking pools and individuals. It aims to be secure, performant, and interoperable in a wide range of environments, from desktop PCs to sophisticated automated deployments. Documentation can be found in Lighthouse book 1. Lodestar. Lodestar is a production-ready consensus client implementation written in TypeScript under the LGPL 3.0 license. It's maintained by ChainSafe System and is the newest of the consensus client for solo stakers, developers, and researchers. Lodestar consists of a beacon node and validator client powered by JavaScript implementation and Ethereum protocol. Lodestar aims to improve Ethereum usability with light clients, expand accessibility to a larger group of developers, and further contribute to Ethereum ecosystem diversity. Nimbus is a consensus client implementation written in Nim under the Apache 2.0 license. It is a production-ready client used by solo speakers and staking protocols, staking pools. Solo stakers, staking pools, both use Nimbus. Written in Nim language. Okay. Designed for resource efficiency, maintained, making it easy to run resource-restricted device. Okay, so means any lesser hardware specification device can run Nimbus. And enterprise infrastructure with equal ease without compromising the stability or reward performance. A lighter resource footprint means the client has a greater margin of safety when the network is under stress. Prism and Teku are still remaining. Prism is a full-featured open-source consensus client written in Go under GPL 3.0 license. It features an optional web app UI, and prioritizes the user experience, documentation, configurability for both stay-at-home and institutional users. User Prism docs for the same. Tech is one of the original Beacon chain Genesis clients. Alongside the usual goal, security, robustness, stability, usability, and performance, Teku specifically aims to comply fully with all the various consensus client standards. Beacon chain Genesis client. Teku offer very flexible deployment option. The beacon node and the validator client can be run together on a single process, which is extremely convenient for solo stakers, or nodes can be run separately for sophisticated staking operations. In addition, Teku is fully interoperable with Web3 signers for signing key security and slashing protection. Teku is in Java and Apache 2.2 license. It is developed by the protocols team at Consensus. That's also responsible for ISO and Web3 signer. Learn more in Teku documentations. So we have read about all the execution clients and consensus clients. Actually, we have not learned. We have just saw that there are several clients, and we at least have some idea of their names, but not everything of their working. What's now? It's synchronization. It's synchronization. Just a second. Just a second. Just a second. Fine. No issue. Synchronization modes. To follow and verify current data in the network, the Ethereum client needs to sync with the latest network state. Synchronization mode. What does synchronization means? To import the current data in the blockchain, the current state of the blockchain. Okay. If you were online from say 2 hours, then you should synchronize that what happened from the last 2 hours when I was sleeping. That's just what synchronization means. To follow and verify the current data in the network, the Ethereum client needs to sync with the latest network state. This can be done by downloading data from peers, cryptographically verifying the integrity, and building a local blockchain database. What they can do is just they can ask the data from the peers, like, hey dude, just give me the data that's generated while I was sleeping. This is done by downloading data from peers, cryptographically verifying the integrity. Download the data from peers. Second, cryptographically verify the integrity and building a local blockchain database. These three tasks are performed by in synchronization. Synchronization modes may represent different approaches to this process with various trade-offs. Clients also vary in their implementation of sync algorithm. Always refer to the official documentation of a chosen client for specific on implementation. Execution layer sync modes. So we'll see for both of them. Syncing is done in both the layers. Execution layer syncing mode, full archive sync. Full sync downloads all blocks including headers, transactions and receipts. Full archive sync. Okay, full archive sync. Full archive sync means a full node is asking the full data from a full or an archive node. Full sync download all blocks including headers, transactions and receipts and generate the state of the blockchain incrementally by executing every block from Genesis. And second, full sync downloads all blocks including header, transaction, receipts and generate the state of the blockchain incrementally by executing every block from Genesis. फिर 3 दिन लेगा. Minimizes trust and offers the highest security by verifying every transaction. It is checking each and every block, man, while synchronizing. Then why would it provide the security? Yeah, it will provide the security, man. With an increasing number of transactions, it can take days to weeks to process all transactions. Yeah, just as I said, that it might take 3 days. Nimbus takes 3 days, not all of them. These take weeks. Full snap sync. वो क्या था? Full archive sync. Okay, that was full archive sync. This is full snap sync. Now we are reading. Snap sync verifies the chain block by block, just like a full archive sync. However, instead of starting Genesis block, starts at a more recent trusted checkpoint that is known to be part of the true blockchain. Node saves periodic checkpoints while deleting data older than a certain age. The same thing goes there, but it don't checks from the Genesis. It just checks from a very trusted block, trusted checkpoint. We can say the node saves periodically checkpoint while deleting data older than a certain age. Those snapshots are used to regenerate state data when it is needed rather than having to store it all forever. Faster syncing strategy currently default in Ethereum mainnet. Ethereum mainnet has currently default of full snap sync. Saves a lot of disk usage and network bandwidth without sacrificing security. Hmm. Security is not sacrificed as the syncing is done from a trusted block, starting from the trusted block, and it saves a lot of disk storage and the time. There's also one more. Light sync. Light client mode. Light client mode. Download all block header, block data, and verify some randomly. Only sync tip of the chain from the trusted checkpoint. What they do? They just take the block headers from other from the full node. Light client mode downloads all block headers, block data, and verifies some randomly only sync tip of the certain of the chain from the trusted checkpoint. Light client mode download all the block headers. Light client mode download all the block headers, hmm, block data, and verify some randomly. It don't verify everyone. It just verifies some of them randomly. It only syncs tip of the chain from the trusted checkpoint. It syncs the tip of the chain. Okay, means what I understood. It's not all the data is taken, is pulled in, but just the headers are pulled in from starting from the trusted block. Geeth only the latest, sorry, gets only the latest date while relying on trust in developers and consensus mechanism. Client ready to use with current network state in a few minutes. Okay, so this sync is performed within few minutes. NB light sync does not get work with proof of stake Ethereum. New version of light sync should ship soon. NB Nimbus. Is it Nimbus? I don't know. I no one told me that its short form is NB, so I can't say it confidently. Consensus layer sync models. There are several consensus layer sync models as well, like optimistic sync. Optimistic sync is a post-merge synchronization strategy. Post-merge, merge होने के बाद वाली. Merge took place in Ethereum. Then after the merge took place, the optimistic sync has been introduced. Post-merge synchronization strategy designed to be opt-in and backward compatibility, allowing execution node to sync via established methods. Execution engine can optimistically import beacon block without fully verifying them, find the latest head, and then start syncing the chain with the above methods. Then after the execution client has caught up, it will inform the consensus client of the validity of the transaction in the beacon chain. Ah, what is the difference? Optimistic sync is a post-merge synchronization strategy designed to be often backward compatible. Backward compatible means it takes all it brings it downloads all the chain and then it starts verifying from the latest blocks, allowing execution nodes to sync via established methods. Now, the execution engine can optimistically import beacon block without fully verifying them, find the latest head, and then start syncing the chain with the above methods. Then, after the execution client has caught up, it will inform the consensus clients of the validity of the transaction in the beacon chain. After the execution client has caught up, it will inform the consensus client of the validity of a transaction in the beacon chain. First, it will import, then it will check, then it will inform the consensus client that yeah, we have imported the blockchain. Checkpoint sync. Checkpoint sync, also known as the weak subjectivity sync, creates a superior user experience for syncing beacon node. Checkpoint sync is also known as weak subjectivity sync. It creates a superior user experience for syncing beacon node. It's based on assumptions of weak subjectivity, which enables syncing beacon chain from a recently weak subjectivity checkpoint instead of Genesis. Checkpoint sync mates are the initial sync time significantly faster with similar trust assumptions as syncing from Genesis. In practice, this means your node connects to a remote service to download recent finalized states and continues verifying data from that point. Third party providing the data is trusted and should be picked carefully. Okay, so this is also a type of beacon syncing where where the synchronization takes place from some weak checkpoint. I actually don't understand what does weak checkpoint mean. It might be possible that it means some checkpoint that isn't that authentic or that trusted, but yeah, it might also be possible that it's referring to the one from where the node has become inactive. That can be the point. So further readings also given, like yeah, we can read them. Fine, I believe that this has become a really long video, so we must just take a rest and we'll start a new video on run a node. So fine, bye, have a nice day. If your day is still left, my day is over now. I'll go to sleep. Bye bye, ta. Good night.